Okay, let me do some problems in this homework. Number four. Question number four asks we find the expression of f of a plus h minus f of a over h. So to do this, we first need to know what are the expression of f of a plus h and f of a. Now, to do this, it's just like uh, when it's just like how we evaluate a function. Say, if we given function f(x) equals negative 6x minus 9, and if we are asked to find what is f of 1, so how do we do this? We gonna substitute 1 for x in the function. So it will be negative 6 of 1 minus 9. So the answer is negative 15, right? Now we want to find what is f of a plus h and f of a. So here what we do is we use this expression a plus h to replace x. So whenever I have x, I rewrite it using this notation a plus h. Okay. Now f of a so this time I replace x with a. Now, if we don't have x, then we just don't do anything. Like we keep the negative 9 because this 9 doesn't contain any x. Okay. Now next we want to simplify these two expressions. So negative 6 times a plus h, we can distribute negative 6. So get negative 6a minus 6h and minus 9. And this is a negative 6a minus 9. Okay. This is our step 1. Now, in step 2, we want to figure out how to write the numerator, which is the difference of these two things. So the difference of these two things gonna be negative 6a minus 6h minus 9 minus negative 6a minus 9. Now we simplify this expression. Since this is minus negative 6a, so after I remove the parentheses, it becomes plus 6a and plus 9. Now we can see the negative 6a and positive 6a are cancelled. Negative 9 and positive 9 are cancelled. So we are left negative 6h. Now the last we divide this expression by h. Since the numerator we figure out is negative 6h. Now negative 6h divided by h. the h is cancelled. So the answer is -6. Right. Okay. Now let me do number 7. In number 7, we are asked to write this two composite function using fx and gx, and then to find what is the domain of the composite function. So we said this notation means the gx is the inner function. So this equals f of gx. So how do you write f of gx? To write to find what is f of gx, we are using the function gx to replace the x in the function fx. So in the function fx, the function is 1 over x. Now if I replace x with gx, this will be 1 over gx. And what is gx? Gx is 7x plus 2. So this composite function f of gx is 1 over 7x plus 2. Okay, now next, we want to consider what is the domain of this function. So the domain of this function, since this composite function we can say is a rational function, right? And we said if a function is a rational function, then the domain will be any number except the numbers that will make the denominator be 0. So which number will make the denominator be 0? Which number will make this expression be 0? So that number, to answer this question, we just need to solve for this equation. So which number will make 7x plus 2 be 0? The answer is the number is -2 over 7. So the domain of this composite function will be every number except -2 over 7. Because when x equals -2 over 7, the denominator will be 0. And if the denominator is 0, we know 1 over 0 is undefined. Okay, but we're not finished yet. We're not finished yet because when we're looking for the domain of a composite function, we also have to consider the domain of the inner function. In this case, our inner function is a gx. So we want to look at what is the domain of this function gx. And the gx, in this problem, the gx is 7x plus 2. Now this function is a polynomial function. This function has no restriction on the domain. The domain could be any number. So if we consider both, then the domain of this composite function will be every number except -2 over 7. So if we go back to the options, then the domain will be every number except -2 over 7. Okay, now let's try another one. Now here we switch the inner function and outer function. This time the inner function is fx. So we're gonna substitute the x in the gx. We're gonna substitute fx for the x in the gx. So gx is 7x plus 2. So now we're gonna write this into 7 times fx plus 2. And fx, we know fx is 1 over x. So this is 7 times 1 over x plus 2. Okay. Now let's take a look at the domain of this function. The domain of this function, since here we have a 7 over x, when x equals 0, this term will be undefined. So the domain of this function is every number except 0. And then don't forget to look at the inner function to consider what is the domain of the inner function. The inner function is 1 over x. Now the domain is every number except 0. Therefore, the answer is the domain is every number except 0. So we should choose this one. Okay. All right. Now let me do number 8. Fx is a square root of x minus 1 and gx equals 2x minus 7. So the first composite function we are asked to find is f of gx. So I'm gonna replace the x in fx by gx, which will give me the square root of gx minus 1. Okay, and then we write down what is gx. Gx is 2x minus 7. That's 2x minus 7 and minus 1. So it is the square root of 2x minus 8. To type this function, we're gonna use this tool. We click on this and type 2x minus 8. All right. Next, we look at what's the domain of this function. This is a square root function, so we want the inside part to be non-negative. In other words, we want 2x minus 8 to be positive or 0. So which number x will make 2x minus 8 be positive or 0? The answer to this question, to the question like this, is to solve for this inequality. So 2x has to be greater than or equal to 8, and x has to be greater than or equal to 4. So we divide 8 by 2. So as long as x is greater than or equal to 4, we will guarantee that this piece 2x minus 8 will be positive or 0. Therefore, the function is defined. So the domain of this function, function is x greater or equal to 4. And then let's take a look at the domain of the inner function gx. The gx, the inner function gx is a polynomial function, so the domain will be every number. If we consider both, the answer will be the domain must be greater than or equal to 4. So we know we should choose B. Okay. Now g of fx. To find the g of fx, I'm gonna replace the x by fx. So instead of having 2x minus 7, we have 2 times fx minus 7. And the fx is a square root of x minus 1. So this is a 2 times the square root of x minus 1 minus 7. Okay, now the domain of this function, so this time we want this piece. We want x minus 1 to be greater than, to be positive or equal to 0. So x is greater than or equal to 1. Okay. And let's consider the domain of the inner function, which is fx. The domain of this inner function is also x is also any number greater than or equal to 1. Therefore, the domain will be this. Okay. Okay. Now let me do number 10 next. On number 10, we have f of gx. So f of gx is a 1 over gx minus 3, because fx is 1 over x minus 3. So that's why f of gx is 1 over gx minus 3. And gx, we know gx is 9 over x. Okay. Then let's simplify this function. So first we write 3 into 3x over x. The reason I do this is to make both of them have the same denominator x. So we have a 9 minus 3x over x. And 1 divided by 9 minus 3x over x. This is equal to x over 9 minus 3x. So this is just like, if you forget about this, when 1 divided by a fraction, this equals the reciprocal of this fraction. So it's 3/2. Okay. After we get here, let's take a look at the domain of this function. Because this is a rational function, we don't want the denominator to be 0. So which number will make this be 0? So that number is 3. Therefore, we have to exclude this number from the domain. So domain is anything except 3. And then let's look at the domain of the inner function. What's the domain of the inner function? The inner function is 9/x. So because when x equals 0, this function is undefined. Therefore, the domain of the inner function is any number except 0. Remember, we need to consider the domain of the inner function as well. So if we consider both, the answer will be B. The domain will be any number except 0 and 3. The domain here, the function is x over 9 minus 3x. Okay. Let's do this one. G of fx. G of fx, that will be 9 over fx, which is 9 over 1 over x minus 3. Okay. So this is like 9 divided by 1 over x minus 3, right? And when we write this into multiplication, this will be 9 multiplied by the reciprocal of the denominator. And the reciprocal of the denominator is x minus 3 over 1. So this composite function is 9 times x minus 3. Okay. And since this is a polynomial function, the domain is every numbers. And then let's consider what's the domain of the inner function. The inner function is fx, and fx is 1 over x minus 3. So the domain will be every number except 3, because when x is 3, 3 minus 3 is 0. Okay, if we consider both, then the domain will be every number except 3. Okay, let me do number 11. So what does this problem want us to do is it wants us to first find out what is the expression for the composite function, and then to evaluate the composite function at this given value. So to find f of g of negative 2, we first need to know how to write this composite function f of gx. F of gx is 4. Now the gx is an inner function, so it's so we replace x with gx. So 4 times gx minus 2, and the gx is x squared plus 5. So this is 4 times x squared plus 5 minus 2. So this is this would be our composite function. Now you can continue to simplify this. So you get 4x squared plus 18 plus 18. Okay. Now then, when x equals negative 2, so this wants us to evaluate what does the function value is if x equals negative 2. So 4 times negative 2 squared plus 18. So that will be 4. Now negative 2 squared is a 4. And 4 times 4 is a 16. 16 plus 18, the answer is 34. So it's 34. Okay. For the next one, we will first need to find what is the function g of fx. G of fx, so we have fx squared plus 5, which is 4x minus 2 squared plus 5. Okay. And if x equals 4, we have 4 times, so 4 times which number? 4 times 4, right? 4 times 4 minus 2 squared plus 5. And 4 times 4 is a 16. 16 minus 2 squared. 16 minus 2 is a 14. Now 14 squared plus 5. 14 squared is a 196 plus 5. 201. Okay.